In this video, we're going to look at something called the distributive property. We're going to start to understand that a little bit, and we're going to use some what we call algebra tiles. So many of you have probably used algebra tiles before. We're going to start and use them fairly simply. I'm going to drag out a couple tiles just to kind of show you what's what. So here's an algebra tile. We call this tile the X tile, and the reason we call it the X tile is that we say that it has an area of X. So remember, the area of a rectangle is its length times its width. So this rectangle we say has a width or a height in this case of 1, and we say that the length is equal to X. So X times 1 gives us X. So the area of this rectangle is X, this value right here. So that's why we call that X. And I think this, sorry, let's try that again. I think this one here maybe makes a little bit more sense now as well. We call this 1 because it has a length of 1 and a width of 1. So its area is 1 times 1. So the area is 1. We call that 1. So those are the tiles we're going to use. And we're going to use them, as I said earlier, to explore what we call the distributive property. So let's get going. So here's X plus 1. When I say that, I mean we have our X tile. And we also have this other tile here, which is a 1 tile. So if we were to write this as a mathematical statement, we could write this as X plus 1. So going from the visual to an algebraic representation might look like this. So now I'm going to ask, what's going to happen if instead of just having X plus 1, we take this statement here and we multiply it by 2. I'm going to keep that there. So I'll just duplicate what we're doing down here maybe. We'll make a copy of all of this just so we don't lose anything. And now I'm just going to drag that down here. And I'm asking you, what's going to happen if suddenly instead of just having an X with a 1, we have 2 copies of that? So 2 times that. Well, 2 times that means we need a second copy of this. So I've already copied it. I'm just going to paste that second copy here, hopefully. That again. There we go. So 2 times X plus 1 is equal to 2 of these. In fact, I'm going to show that as a separate line over here. Let's try that again. We'll copy this. It looks something like this. So this is equal to this. And let's think about what this represents algebraically. So if we were to write a mathematical statement showing this, well, you can see here that there's one X here and another X here. So that's a total of 2 X's. And we have a 1 and another 1. So we get 1 plus 1, which is 2. So 2 times X plus 1, or 2 groups of X plus 1, is equal to 2X plus 2. Hopefully that's fairly straightforward. Let's try one that's a little bit different. Call this maybe example A, and we'll call this one example B. Try to do that a little bit further down so we don't lose anything. So what about something like, and I'm going to go backwards here. What about 2 times X minus 4? How do we represent that? So we're going to show it as 2 groups of X minus 4. So let's draw out X minus 4. So X minus 4 will look like this. Here's my X. And the way that we show minus, I'm going to drag out 4 of these 1 tiles, and then we'll talk about how we can make them negative. So there's 1, 2, 3. Probably could have just copied those, and I could have just chosen 4. All right, so this is actually 2 times X plus 4. We don't want plus 4, we want minus 4. So I'm going to highlight these 4 tiles, and I'm going to click on the plus minus, and now we have X minus 4. All right, so 2 times X minus 4, what does that look like? Well, let's get a copy of this because we want 2 of them. We'll just make a copy. And I think what I'm going to do is, again, I'm going to keep it separate just so we can see all the bits and pieces as we go here. We'll copy it one more time. So there's our first copy. Here's our second copy. just bring out the annotation tool. So 2 groups of x minus 4 looks like this, and we're just going to count up the x's, and we're going to count up the minuses. So 1x here plus another x, that gives us a total of 2 x's. And minus 1, 2, 3, 4, 5, 6, 7, 8. So we had 2x and then minus 8. So that's what we're doing when we do this distributive property. So this idea is called the distributive property. Now, you might be looking for a shortcut. You can see we took a few steps to get here, and that's okay to take steps. I want you to understand what's going on. The shortcut that we could take, though, and the shortcut that you'll get comfortable with eventually, is that 2 copies of x plus 4 really means we're going to have 2 of these, and we're also going to have 2 of these. So the shortcut, what we would normally call the distributive property, is that we can multiply this, called the coefficient, that number out front being multiplied, by everything in the bracket. So 2 times x would give us the 2x that we had in our final solution, and 2 times negative 4 would give us the negative 8 that we had in our solution as well. So let's take this one step further. In fact, we're going to do 2 more examples. I don't know if I can fit them all on this screen, but I'll do my best, and if not, we can add a new screen. So let's look at 3 groups of x plus 2. So see if you can pause the video and see if you can kind of figure out what the result will be here. This is called expanding, by the way. When we take this 2 and multiply it by everything in the brackets, it's called using the distributive property to expand. Sometimes we just say expanding. So see if you can figure out what that's going to look like, and then we can come back and have a look at the visual representation just to see if you're right. All right. Hopefully you've had a chance to pause the video and to work things through. So I'm going to set this up the same way that we did the last time. I want 3 groups of x plus 2. So I'm going to show my x plus 2 in the brackets. So here's one of these x's. And I'm going to do a plus 2. All right, there's 1 and there's 2. So I want 3 of these. So again, I'm going to create 3 copies so that I can have an equal sign here. Let's add in the equal sign. Add in the equal sign over here, and we're going to create our 3 copies. So we'll highlight this, we'll copy that, slide it over a little bit, and we'll do the same thing here. I like to stack mine. You don't have to do that, but I find it easy to group all of the x's together and all of the 1's together. All right, and now you can see that we have how many x's? Well, we have 1, 2, and 3 x's. So we have 3 x's, and we have 2 groups of 3 1's. 2 times 3 gives us 6. And there's that 2 times 3 that I talked about earlier, right? 2 times 3 comes from here. So yeah, the distributive property says take that 3 multiplied by the x, we get 3x, which is what we had. And take that 3 multiplied by the 2, and we get a 6, which is exactly what we had over here. So there's our answer there. All right, I said we were going to do one more example. So here it is. It's actually very similar to this example. I think I might try to do 2 more examples, but let's start with this one right here. So I want you to think about, what does negative 3 times x plus 2 look like? What might it look like? We already know what 3x plus 2 looks like. What do you think negative 3x plus 2 is going to look like? Well, it should look like negative 3 of these. And the negative might throw you off a little bit here. But remember, the negative is just the opposite of a positive. I'm just going to slide that down a bit more. Here we are. Grab my pencil. So we want negative 3 of these. Well, that means we need 3 copies, but we need to make them negative. So when we make them negative, here's our 3 copies. I may as well just copy all of this because we've got it here already. Save us some time. Here are the 3 copies. then we want to make that negative. Oh, hang on. I didn't want that to attach there. So I want to make that negative. So I'm just going to stick this little negative out front. And I'm going to put some brackets around here so we know that all of this has to be negative. Well, we had 3 x's before. And again, we're going to make the x's negative. So if we had 3 x's, we're going to make them negative. There'll be negative 3 of them. And then we're going to take our 6 that we had before and make that negative. Sorry, I forgot my x here. So if we make 6 negative, we get negative 6. So again, the rule was the same as it was before. We take that negative 3, we multiply it through the brackets. Negative times a positive gives us a negative, and that's where we get the negative 3x. And negative 3 times a positive 2 gives us a negative 6. So that's how we can use the distributive property. I want to show you one more example where we have a number in front of the brackets. So let me just clear some of this. I won't get rid of all of it because some of the stuff at the bottom might be useful for you to use later on. But let me just get rid of this first example here. And then we can do one more example. So let's have a look here at what, hang on, there we go. So this will be example E. So example E is going to be, whoops, that was supposed to be a 2. Let's try that again. All right, so example E is going to be 3 times 2x minus 4. Now, you can see here the difference is that instead of going with just a single x value, there are 2 x's here. So there's a coefficient in front of the x term. The same rules apply. So we're going to start by showing 2x minus 4. Let me grab the x's. Here are the 2 x's. Now there's 2 x's, and that's okay. And I'm going to show the minus 4. So I want the minus values, and I don't know, let's go, we'll grab 5 of them. And then we can delete one. All right. So there's 2x minus 4. We've got the 1x on top, the second x on the bottom, and we have our minus 4. Now we need 3 of these groups. So again, I'm just going to keep track of this. I'll put an equal sign here. We need 3 of these things. Oh, sorry, I changed my pen color. Forgot to change it back. So 3 of all of these. So let's highlight everything here. That's not how you highlight it. Let me try that again. There we go. Highlight all of this, and we want 3 copies of this. So we'll copy once. Slide it over a little bit. Here's our second copy. Again, I'm just going to line up the x's. Oh, that's not what I wanted. There we go. And here's our third copy. So we'll add in our equal sign. So it equals all of this. You can see that this gets a little bit cumbersome when you're trying to use the tiles for really big numbers. So what we're going to do is we're just going to count these all up. 1, 2, 3, 4, 5, 6 x's. And we have -1 4 times. So that's our -4, but that's happening 3 times. So -4, -8, and then -12. All right, so, and again, you can see that that same distributive property that we talked about, multiplying that coefficient by everything in the brackets, 3 times 2x. Well, 3 times 2x, 3 times 2 is 6, so we get a 6x. And then we have 3 times -4. Well, 3 times -4 gives us -12. So that's how we can use the distributive property and how we can use tiles to represent the distributive property.